Okay, so hi everyone, this is Vivek, and in this particular video, I'm going to be talking about dynamic programming and my suggestions to level up faster in the same. So there has been a lot of comments on videos of my channel that, hey Vivek, go ahead and make a video on DP and how to improve in the same. So this is there now, and this is not just going to be a Gyan video or like just a funda video. It's going to be more like solid points that you can take up and actually improve your game. There is going to be an announcement at the end of this particular video, which is regarding how this channel is going to go forward. So do stick around if you like the type of content that is there on this particular channel, and do consider subscribing the channel if you have been liking it. I mean, do pause it, go and subscribe it, and then come back. That helps me a lot. Okay. Anyways, let's continue with the points. So in a discussion with one of my students, generally this question often pops up that, okay, why is DP so difficult and frustrating and all? And that's understandable. Like, I think this is the most common query that I get. In fact, if you go ahead and ask someone what is the most difficult topic in dynamic in competitive programming in general, most probably they're gonna pick DP, and it's understandable. Let's decompose why it's so. Okay, the number one point that I feel why it looks difficult is there is a paradigm shift from sequential to recursive when you first start with DP. That means most of the processes that we have been doing, like looping, if else, and all these things, these are mostly sequential in process. Like you have a sequence that you can follow. But recursive definitions are pretty difficult to track, and you have to see those recursion stacks and all to kind of understand. So that makes it difficult to first of all like visualize the process, how it is working and all. And that's what is like one of the points. Next is, I think it takes around like 25 to 30 problems to kind of get hold of, okay, what is happening in the structures and how to kind of build the solutions and all those things. So in other problems, like in if else and other things, like from the first problem itself, you start getting more and more things. But in over here, I think I personally feel that you need to have at least like 25 problems solved, and then you get more of a feel on why these recursions are working and how the recursions are actually building the solutions and all those things. So that's why like it takes some time to build up the like basic building blocks or the mental idea that is there in this DP. And that's one more point. One more point is that there is a vast list of ideas and states and optimization. So that is like one more reason. There are a lot of different ideas, a lot of different state kind of constraint modeling ideas and optimizations as well on top of them. So like you have to really solve a lot of problems to get these ideas, and that's what like I think makes this one more difficult. And one more point is there, which I think is more subtle, is that because everyone says so, right? Because most of your friends whom you have been talking to says that DP is hard, and then you believe that it's hard. And when you start with it, okay, you have an excuse with yourself that, okay, I know DP is hard, so if I'm not able to understand this problem, most probably because DP is hard. So this is, I think, the most like used reason by people to kind of neglect DP, but you should not, because I think uh, anyone who is going to go forward in this particular field has to master this particular topic. Okay, so according to me, DP is about understanding how these frameworks of forms work. So basically this DP, I'm not talking about all problems, but most of the problems, in fact, most beginner, intermediate, and like even medium hard problems, right? For hard problems, it get mixed with other topics. So it's not about that, but most DP problems can be decomposed into a form. So let's say you're given a question, you recognize that it's a DP problem, then you see there is a proper framework you can follow, that you can see which form it goes into. Like there are different kind of forms there are, and for each form there is a different mechanics that works, and different kind of transitions you set, different kinds of states you take in the parameters and all. So there are different forms according to which you solve the problem. And if I just give you a simple example, like for object choice, you have knapsack and subset somewhere. You're like, for every object you have a choice that whether you take it into the subset or you don't take it, and according to that the whole like choice is made, and you have to optimize some function. Then ending form, like what is the best ending solution at a particular endpoint, and so on. LRDP is for interval kind of problems. Then matching form is basically where you have to match characters between multiple sequences. Then game, of course you have games and all where you use DP to find whether the state is winning or losing. And then there are tree DP, digit DP, bitmask DP, and there are so multiple different forms. So understanding these forms independently helps you to actually bring about understanding in the code how to write individually the form styles. And then once you have understood them, you can actually use the like any new problem to understand, okay, which particular modeling can it go into. And to be honest, there are just 5 basic forms and 3 like intermediate forms that you need at the start to kind of solve almost intermediate level problems, like I would say 2000 to 2100 level problems in platforms. So that much is almost sufficient to kind of expertise to a create level. Okay, in fact, like even in these forms there are sub forms. Like when you go to tree DP, you can even break it down into like in-out DPs, which I think some of you might be aware about. Knapsack on subtrees, like you have different subtrees, there are informations, and they do knapsack on top of that. In fact, there was a last video, the Facebook Hacker Cups qualification rounds last question was in fact on this topic itself. Then ancestral ideas are also there, which like you keep some property of the ancestors by which you're building the thing. So these kind of ideas do come up often. Okay, so that's where you have to practice. This comes with practice, but again, for every kind of form, you have to make sure that you understand how the like building of transitions and states work. So this form kind of a framework is something that is important. Though I'll not be talking about these forms in this particular video. It takes me around 12 hours to teach all of these forms and all in general when I teach them. So that's not like going to be the part of this particular video. Maybe I'm going to take sessions or make videos on top of that, so to complete these things. But for today, let's move to the main suggestions for that, for which particular things you are over here in this particular video. So my number one suggestion would be to practice backtracking before you move to DP. A lot of people start with DP and then realize that, okay, they don't have their recursion concepts clear and all. So I would suggest that there is this particular topic called backtracking, which I would suggest anybody to start with when they are in fact coding. Once you're done with C++, I would suggest you can start with backtracking itself, because number one, it builds your good implementation skills. Number two, it builds your recursive thinking, because no matter how much practice you put in, unless you are clear with your recursion concepts, I don't feel somebody can become a great coder without understanding recursion. So you will have to build that recursive intuition that, okay, you are having these parameters and you are passing it to the function. It will give you the return value, and if you are merging them correctly, you will get the correct solution. This intuition that you're building for the problems, this has to come, and that generally comes with backtracking. So I would highly suggest that you practice backtracking first, because in backtracking you also see the terms which are there in DP. Like you have to model the problem in a backtracking way. You have to find states that you keep, like some configuration states that you have to keep so that you can keep track of what is happening or not. Pruning is a concept where you have to like remove some solutions because they are obviously not possible from that particular branch or so on. Recursion, obviously, like you will write backtracking. Backtracking is a recursive code. Generally written as recursive code. So that's why you have recursion in that. Then DP is nothing but just a backtracking plus memoization. If you understand backtracking, there is some changes in the states and transitions, and apart from that, you just use memoization. That's it. That's DP. So if you are understanding backtracking, it's just all of these stuff plus this memoization. So you're almost done with DP if you're done with backtracking first. So start with backtracking. Okay, that's number one. Number two, practice recursive code at start. This is something I feel a lot of people don't generally do, but I would highly recommend anyone doing DP at the start to do so. That start with recursive codes. Someone senior might already tell you that, okay, recursive codes are not optimal and they might not give you the best performance. Sometimes you might get TLE due to a lot of recursion stack or so on. But believe me, writing the first few codes, first 30, 40, 50 problems in recursion style is going to build, number one, a lot of different state ideas, and number two, clear thinking between how the states are transitioning. So that formulation of states and their transitions is going to become much more clearer if you write it in this way. And also when you write iterative style codes, there is this dependency on how you loop, the order of loop and all those things. In recursive code, you just like neglect those things because they are not important. The recursion will handle like whichever way it's actually required, it will find the value automatically. So you don't have to think about it, right? So write recursive codes at the start. You will learn a lot of different things. In recursive code as well, you have a lot of a simple function, like a functional structure that you can follow. Like simply you have the array, like the base array, which you save for a particular question, the cache array basically, and then the function. Then you write a pruning statement for a particular problem. Then you write the base case for the problem, right? Then you write the cache check whether it is already saved or not. If it's saved, return it. If not, then compute the value and then save it in the cache and then return. This is a very simple structure that you can follow for any particular problem that will help you to solve the problem. This is a general writing style. Let me give you an example. Like this is just a simple knapsack problems code. I just wrote it quickly. So it's like let's say if you are using the ith item, if you're at the ith item and the current weight that you have taken right now is CW. So in case at any point in time this current weight of the taken items is greater than W, so there is basically this particular setup, right? There are these items and then like you are at the ith item and then you are deciding whether to take it or not take it. So if you take this particular item, then you're going to go into I+1 next item and you have got a CW plus the current item's weight. And if you don't take it, then you remain with the CW weight. And if you take it, the total price that you're getting is going to get increased by P. So this is the profit side, not price, profit. So this is how the general like transitions of knapsack work. But understanding the coding structure is more important because you basically have the same structure: function, the saving array, the pruning statement, the base case. Like if you reach the final thing, like all the n elements has been processed and you are at the last element, there is nothing more to process, simply return 0 because you cannot get any more profits. If it's already saved, return that saved value, or else compute the value and save and then return that value. So this is a very simple structure that you can follow for almost any problem. Personally, I feel that very few, like one or two problems which require some data structure alongside DP might need iterative code. Rest every code can be written recursively, and it's almost like 50% of the time you're going to see that it doesn't really matter which one do you write. So if you just master one of them, you're going to be good. Another reason is in interviews, writing recursive codes are generally like recommended because it helps you to like explain the things as well as write the things. But in like loopy codes, you have to write the loops and you have to explain, okay, why you're looping in this manner and all. So I generally prefer like writing recursive codes at least in interviews, and this is going to help you in interviews as well. So this is basically the coding part. Number suggestion 3 I would give is watch people solving DP problems, right? This is something I feel like has helped a lot of people. This is something I did not do myself. And I feel now when I teach people DP and I just show them, okay, this is what I'm thinking, this is how the states are working, this is how like you're thinking about the process, and this is how like the transitions for the forms are working, this is how you're setting up the code, this is how you're like, this is the flow that you're following. And for every problem, when you're seeing that, okay, this is working and all, you get the confidence that, okay, this is how it works, and every time I can take this particular thing. You have to understand, like, there are simple things like when sometimes the values can be negative, you can take, let's say, the cache array. You cannot take cache array's default value as -1. You have to take something else or so. These things, these subtleties, you understand only when you're solving, like when we are watching people solving and when they explain the ideas. So this is something that I would highly suggest you to do. I went through the YouTube channel and there are a lot of videos you can watch. I think if you are an English like viewer, you can go for Edicto's DP playlist. I think there is DP videos that are there from the AdCoder series. You can watch that particular one. In fact, if you're just Hindi listener, then Karthik Arora ka channel bhi acha hai. Like you can watch that particular channel, right? In that there he has made good videos on like DP, so you can watch that particular thing. If you're here for interviews and all only, then I think Tushar Roy's DP playlist is very famous. There are like around 40 problems on the interview DP questions, and you can basically follow that particular thing for solving questions. And in fact, I'm planning to put more such questions, like explaining how you are thinking about a question in this particular channel as well. So that would be up soon whenever I get time. But like feel free to comment on any particular source that I might have missed on, because like this is just the quick things that I've found. There are more, there might be more. As I said, I did not use this particular technique myself, because by the time like I was doing all these things, I was like, I realized that this is there as a better method. I was already pretty much senior, so at the start, but this is like whoever I'm teaching right now, they have been helped a lot by just seeing me code this particular things, like just explaining the things. So do watch people solving things. That actually helps. Okay. Next, a lot of people struggle with time complexity of DPs. I'm going to give you a simple rule that you can follow to write time complexities, to find time complexities of code that uses DP. Okay. So most probably you have a code like this where there is a DP array, there is a DP A comma B, and you have like some internal DP dependencies, like they have transitions into two different DPs, right? Then there is a main call and there are some DP calls, right? And there is this cache array. The simple formula that you can use to calculate the code mentally is assume as if every DP array, every cell of DP array is going to get set once, okay? And then assume all the other recursion calls are as if they are cache lookups, okay? So what we are saying is simply assume that we are filling this whole DP cache array first and then making all the rest of the DP calls. Now for calculating the initial time complexity to fill up the whole cache, the simple formula that you can use is this: time complexity is equal to number of states multiplied by 1 plus average cost of transition, okay? And in most cases, this is the number of transitions. So you can take number of S, so I can take a quick screen, number of S multiplied by 1 plus number of T, number of transitions, okay? This is actually cost, which means like if you're checking something and that takes linear time, then that would also be added over here. That would be like multiplied over here in N as such. But note that there is this word average. In most questions, it's like 2 or N or so, but in average, it might so be that for some particular problem, it might turn out log N. So there are more questions which might have better requirements. So keep this term in mind. Okay? But for most problems, this is going to be sufficient. Number of states multiplied by 1 plus number of transitions. Just find this out. For example, this A can take the values in the range 0 to 1000. B can take in the range 1 to 100. Okay? And let's say there are two different transitions, right? There are two different DP calls being made in this DP. So the time complexity for this would be, there are 1000 states over here. So 1000 multiplied by, there are 100 states over here. So there is 100, right? Multiplied by, there are two transition calls. So 1 plus 2. Simply this is your like like DP's complexity. And in fact, let's say if this has a maximum range up till n, and this is up till m, and this is just 2, then you write this as n, this as m, and you write order notation. In that case, it will be order n into m, right? So this way you can calculate the time complexity of a DP. So this kind of a technique comes in handy if you don't want to think too much what my kind of complexity is, because sometimes you have to cache across test cases, sometimes you have to cache across queries or so. So in those cases, just think that like this DP calls are as if like a lookup, and just add this particular time complexity to your code. Okay, so this formula can help you with time complexity. Next, build collection of state ideas and constraint models. Now this is, I think, the most important point of this whole video. In fact, that rest all you might already know. This is something I feel is the basic gist of what people say as practice in DP. Like when somebody says that go ahead and practice DP questions, what they're actually telling you is to kind of build a collection of constraint models and state ideas. Okay, now the state ideas that I'm talking about is mostly like the forms itself, forms plus some constraint states, okay, which comes from constraint model. Let me explain what this is. So this is just a quick idea, but this is not universal, okay, what I'm talking about next. But for majority of the problems, at least the classical ones like knapsack, if you're looking up for interviews, this is going to be sufficient for almost all problems. But in general, like even for most classical ones, and like in fact 90% of the problems, what you return from the recursion is the question being asked in the problem. Okay, then there is some state which is for the form, like which particular form this question lies in, and that particular form decides what is going to be there over here. Then what is the constraint in the problem, which means out of all the, let's say, knapsack problem, out of all 2 to the power n subsets, why is a particular subset not being chosen? Okay, how to model that particular constraint is what we come over here. So there is 2 type of constraint. One is numerical constraints, like you have the value, like there are values, numerical ranges for the values that are given in the question, and that of course helps in DP. I'm talking about a different kind of constraint, that why a particular solution space is not actually included in the solution. What kind of governs that? That is what we say as constraint state over here. Okay, let me give you an example, like that will make it more clear. So let's take simple question, like not so simple in fact. Let's say there are n items with vi value and wi weight, right? Standard knapsack setup. Let's say we have to find the maximum value you can like create by selecting less than equal to k items, and the sum of weights of the selected items should be less than equal to w. Okay, so this is kind of the main problem over here, like find the maximum value that you can create. And for any particular subset that you create, so out of these n elements, you are going to create a subset, right? Kind of, you're creating a subset, and whenever you have this, you have to find the sum of the values of the individual items. So their v's get added up, and for a particular subset, the sum of v's is the basically the main value of the collection. You have to maximize that. Okay, so if you want to try this problem out, like if you think about it, just pause the video right over here, but let's go ahead and discuss this particular thing. So mostly this is kind of creating a subset. Now when you practice forms, you understand that okay, when you're creating subsets or not, this goes into form 1, which is like object iteration form, and in that particular thing. So this particular forms part I'm going to skip in this particular video, because it's pretty large to cover in this one. But what we understand is it's basically like knapsack kind of thing, where we have, let's say, these objects, and you decide whether to take it or not take it, right? So we basically take DP of, let's say, which item you are currently processing, and this is the basically form state, okay, which item you are currently processing, and there are 2 transitions. Based on that, you can always write based on the form modulation. Now there are these constraint state, right? So given a collection, let's say you build a collection out of the items, why is this collection not going to be in the solution? Because it might so happen that the number of items is greater than equal to k, or the sum has exceeded w, right? So if you understand what is kind of restricting is the number of items and the weights, sum of weights of item, right, that you have taken. The number of items taken and sum of weights of item taken are the 2 new constraint states that you have to keep in the question, in the recursion, and this itself is going to help you to solve the problem. And this is in fact the correct state for this problem, right? This is how you form the solution ideas, because you have to understand that whenever you're given this kind of problem where you have to find less than equal to k item, or the sum has to be less than equal to w and all, so what do you keep in the state? This is exactly the constraint models that you learn, and this is what people say as practice. Like when you have to practice the problem, when you have to practice DP, you have to build a repertoire of all these kind of techniques that are there in the problems. Okay, let me give you another example. Okay, let's say you have to find the number of numbers in the range L to R which have the difference of neighbor digits less than equal to k, and the number is divisible by 9, right? So how to do that? So you can see that first of all, there is few restrictions over here. Number has to be in the range L to R, right? This is one restriction. Difference of neighbors has to be less than equal to K, number two restriction, right? Number one restriction, number two restriction. And the number is divisible by 9, number three restriction, right? So you have to know how to model all these restrictions in a particular problem. Now, if you have practiced some DP by now, you know that whenever you have to generate numbers in this particular range and you have some digit based property, it's a digit DP problem. And for this particular thing, there is a very standard DP state, DP of like which particular like digit you are currently processing, like which digit you are currently processing. I would say like I just only, this is the digit. And there is a low and high. This is basically tights. There's something called tight in digit DP, which basically says that whether you are exactly equal to L or exactly equal to R or not. Okay. So this is basically the states for this first constraint. Okay. Difference of neighbor less than equal to K. So in that case, if you are building the number like this and you are placing numbers like this, like 3, 5, 7, if you have to place a new number over here, you need to know the last number, right? So that you can decide whether it is like at a distance less than equal to K or not. So you put last over here, like which particular last number was there that you placed, right? So you have to keep that as a parameter. So that takes care of this third, because now you can simply loop in the range so that the difference between the neighbor is not exceeding K, right? And then there is this third parameter, and that is the number is divisible by 9. So in case you don't know this, like if you have to find a number which is divisible by 9, the sum of this digits should be divisible by 9, right? So you keep sum of digit mod 9 in the state. This is how you model this third parameter, because like if you have the sum of digits mod 9 and if it is at the end 0, that means whatever number you have currently formed is actually divisible by 9, right? So this is how constraint modeling works. For every possible constraint, they have a way to model it. Okay, and this is what you learn from practice. Okay, this sum of digit mod 9, there are multiple such ideas, like if you have to keep a flag that okay, this particular event occurred or not, like this triggers this, so you just keep a flag that okay, this worked or not. If you have to maintain subsets, then you have masks for them and so on. So different kind of ideas are there to model different kind of constraints on top of solution. Like all numbers could have been the solution, but what is restricting a particular number? These are the properties that are restricting, how to model them in a problem. So this is what you build with practice, and this is what like you have to learn. So as you practice questions, keep in mind that this is what you are learning. So this is what you have to like be picky about when you are solving a question. That coding and all is fine, but keep in mind that this is what you learned. Okay, so this is there. A lot of people just would say me, okay, this is a 5D DP, what is this and all. I just say that like dimensions in the DP doesn't really matter. It's not about like how many states you have. It's more about like there is this constraint, how do you model it? Just keep it in the parameter. That's it. That's all about DP. Okay, now this is the fifth suggestion. Let's move to the next one. In fact, this is the last one. Okay, and this is more for an intermediate people, that if you have already done the previous steps and if you are good with some problems, look at ideas of DP optimization. This is also something that like comes up as a decider problems in general, like medium hard problems, and would help you to like ace some competition. Most probably like you have ideas where there is idea of state space reduction, where one of the states can be dropped by relation with the other things, right? There are ideas with pre-computing stuff, like you can pre-compute based on whatever is given in the input and save something that will help you to compute the DP, right? A lot of times like we are computing some DP and like that needs like sum of the previous rows, some k numbers, and so in these kind of problems you can keep prefix sums of the previous row, or like different kind of optimization based on what all like values are actually needed from the DP cache array. So just think in terms of like what all values are required and can be kind of pre-process or save them in some way. Maybe to solve a particular DP, you need another DP to solve it. And that is perfectly fine. In fact, prefix sum is a DP, right? Pre-computation means prefix sum is also a DP, right? So that's also there. And of course, after this also, there are more advanced techniques that I would say, like only if you're senior, you should go for. Like there are advanced DP optimizations, namely convexal optimization, then divide and conquer optimization, Lagrange optimization, like alien trick basically. Then there are more such ideas like 1D DP, Knuth optimization, then monotonicity observations are there, and there are more such like ideas that are there in advanced form. But I think these are very rare nowadays in competition, and I would suggest like you can do these first. Okay, so this is there for more of intermediate people, and this is quick summary of the points that I talked about. So practice backtracking before DP, number 1. Number 2, recursive coding. Please do this. I mean, I would highly recommend you to do recursive coding. Why? Because that will build you first, number 1, recursion habits. Number 2, it will help you to remove a lot of dependency problems. Like a lot of people write loops without understanding which state it depends upon, and then like make a mistake, right? And then like just mess up with the code. Also, when you're writing recursion, you understand that, okay, this is what you're keeping as the recursion parameters, and this is the meaning of the function, that this function returns this. How do you combine the solution? These concepts that you're learning in while writing recursive codes is very important. And this is what I feel like makes someone a bit senior in DP. Like if you have got that intuition of DP, of the recursive style of DP, that you're merging solutions and building the idea, then I think you are pretty much over the beginner stage. Okay. Next, watch people solving DP problems. I will try to make more videos on this one, but for now I have already recommended few back in this particular video itself. Also, like if you are not sure on all of these things, like you can watch few of the previous videos as well where we talked about PSP, problem solving paradigms. So you can check that out. I've given you a simple rule for time complexity if that is confusing for you, though I would suggest like you can try and compute it yourself, but the rule that I gave also works, so you can simply use that to find complexities of the code in case you are struggling with that. Okay, this is the most important thing that people say as practice: build ideas like collection, basically state ideas and constraint models. That how do you model this particular constraint in a problem, right? And then finally, look at, if you are already done with these first 5 points, if you want to improve more, look at ideas of basic DP optimizations, like at least prefix sums of previous layers, pre-computing like prefix sums on normal arrays that is already given to you, and like keeping state space reductions are pretty common. So these things would be something that you should definitely look at. Okay, so these were my 6 suggestions for you to help and improve in DP. So I hope these all make sense. If you have any query on any one of them, please comment me like what this particular point meant and how to do that. Also, please, I read all the comments and I would definitely go ahead and like help you with that particular thing, right? Also, I'd be adding one particular doc link in case you want to get some DP questions. Now, this is not like very chosen problems. This is something I started with. Like this is a collection of Spoj problems. So you can try and solve these problems. There are pretty good problems, like at least Martian and all in this particular blog that I'd be giving, the particular doc I'd be giving you is pretty nice. Okay. In the next video, I'll be talking about maths. So I'm planning on to go into maths. I think in the last video, I talked about like few of the things that are there that we can do in on the channel. So this is like quick announcement on the future of the channel, and we'll be doing maths, right? So this is 3 videos that I'm planning on, 3 sessions or videos depending upon how we grow. So I think this is something I'll be starting once we like go a bit more on the size. So this is basically something we would be doing first, then this and this. So this is like a bit bigger than what we have been doing on the channel. Like I think each of them might take more than 2 hours. So I don't know if how many of you can sit for that long. I'll be trying to break these videos into smaller chunks, but feel free to let me know on your suggestions, like what we can do in these kind of things, what you're expecting, what you would suggest to me to add on these things. And when I say like these topics, I would be adding some basic things, but I'd be also talking about a lot of interesting, like foolproof concepts. So it's not going to be like something we talked about and something did not. We were talking about a lot of internal concepts, not just theoretical things. Mostly a lot of theoretical things are already available in blogs. I'm not going to be repeating all those things. I'm going to be talking about how to apply them into problems. Okay. And one more thing, I'm going to be setting videos targets from now on. This is going to be like a new thing that I'm testing on. So if you like the content that I have been putting on the channel, please do help us grow this particular family. So one particular thing target that I'm going to put is like, I'm going to be putting a target of 1,000 likes, which is very ambitious for this particular video. And I think this particular video also has some value. So if you actually use all these points in your DP practice, right, I'm pretty sure that you'll be improving very, very faster. Okay. And if you have this, if we reach this 1,000 likes, what I'm planning on to is take a live class on this particular channel, which is going to be something out of the box. I think I've never thought about doing this, but now, like, since if you guys make this particular thing true, I'm going to make sure that this is going to come true. Okay, so we're going to have live classes, and whatever things we talked about, these forms and all, most probably we're going to talk about that in a live class. So if you guys are interested in that, do share it with your friends and like help us grow this particular thing. And if you like this particular video, do like the video. Obviously it's included in the target because the YouTube hours algorithm is like that itself. Like it helps us to, it basically promotes then, and more people can see this kind of content. And do subscribe to the channel if you like to get notifications on such more content that we're going to get. In fact, like if in case this is something I'm thinking about, tell me if you guys want this. Like maybe these things can also be done in a live format. Okay, this is something I'm thinking in my mind right now. I think I would need your suggestions on this one in the comments. So tell me in the comment, like if you want to go on a live way, or in a structured way, like recorded video way. Both are good. Okay, but I'm going to be leaving it up to you. So do share it with your friends, whoever you think would be helped with this particular DP fundas. And in this particular video, this is all that I had to cover. Okay. In the next one, we'll be going with maths. Okay. So that's all for this particular one. Chalo, bye bye. See you in the next one. Signing off.